Okay, so as I mentioned previously, today's mock AP has 3 questions. We're going to go through the first question together. So the first will be a model that I'll do in this video. My hope is that this model will be like as clear, as straightforward as possible, and will help solidify some of the concepts that were most confusing last week in our mock AP last week. Once you're finished watching this video, you're going to move on to the next 2 questions of this mock AP, which you can find on AP Classroom. You should be able to open up the same assignment that I'm using in this video on your own AP Classroom. And then for the last part of the lesson, you're going to be answering question 2 and answering question 3 that are all related to the same research design type of question, because that's just the hardest thing. So we're going to keep practicing it. Okay, so question 1. Researchers conducted a naturalistic study, meaning they were observing children in their natural environment. They weren't bringing them into like a controlled environment of a lab to study them. They were just studying them in their natural environment. Of children between the ages of 5 and 7 years. The researchers visited classrooms during class party celebrations. So again, they're going to visit children in their natural environment of classrooms to see what they act like in their normal daily life, rather than bringing them into a controlled laboratory psychology experiment environment. As a measure of hyperactivity, they recorded the number of times children left their seats. Okay, so this is how they're operationalizing hyperactivity. So hyperactivity, hyper meaning over activity. So children being like really active and moving around, jumping around, not being able to stay in their seats. That would be hyperactivity, being hyper. To operationalize or to measure hyperactivity, they recorded the number of times children left their seats. So you can imagine there's like an elementary school classroom, children between the ages of 5 and 7, and then there's psychologists with like their clipboard sitting in the back saying, oh, look, she left her seat, he left his seat, like recording the number of times that children left their seat during class party celebration. The researchers found a strong positive correlation between sugary snacks offered at the parties and hyperactivity. So they found a strong positive relationship between sugary snacks and hyperactivity. So the more sugary snacks, cupcakes, cookies, candy that these children were eating, they noticed the more that they tended to get out of their seats. Based on these findings, the researchers concluded that sugar causes hyperactivity. So already, like an alarm is going off in my mind, because the previous sentence said the researchers found a positive correlation between sugary snacks and hyperactivity, and then they concluded that sugar causes hyperactivity. So you already should be like, correlation is not the same thing as causation. Just because the more snacks you eat, the more active you are, doesn't mean that the snacks are causing the children to be hyperactive. So you should never see these words together, because correlation does not. Just because 2 variables are correlated or related doesn't mean that one causes the other, because as many of you mentioned in your responses last week, there's just too many other factors. So we don't know what if there's some hidden third variable that could be causing students to eat more sugar and also causing them to be more hyperactive. Basically, it's not controlled enough. We don't know what's going on, so we can't be like, yes, sugar causes children to be active. That would be very unscientific to conclude that. Okay. So the first thing we're asked to do, How might the following explain why people may easily accept the conclusion of the study described above? This is a little bit of a weird question, but basically they're saying, say that me or you were reading about this study, and we're like, oh, the researchers are concluding that sugar causes hyperactivity. Why might we easily accept that conclusion? Why might we not be like, I'm going to question that, or I'm going to look more into the methods of the study before I accept that as like absolute scientific truth? Okay, so first up is confirmation bias, which, as we know, is the human tendency, one of our very endearing human tendencies, which is we love to believe things that confirm what we already believe is true. So we love to search for information that confirms what we already believe. Again, we're humans. We like to be comfortable. We like to think we have the world all figured out and everything is in order. So we like to look for information that tells us, oh yeah, my beliefs are true, I'm right, because that's just more a comfortable way to live. Okay, so how might confirmation bias cause me or cause people to easily accept the conclusion of the study? Well, if I already have a belief that sugar makes children hyper, then of course I'm going to accept the results of this study because it confirms what I already believe to be true. So let's see, A. Okay, so I typed up my answer here. I said, first sentence definition, confirmation bias is the human tendency to accept information that affirms what we already believe to be true. Originally I had written the word confirms here. And then I was worried because I was like, oh, that might be too repetitive because confirmation bias. So I just changed it to a synonym, affirms. That affirms, or that, I could even just say that agrees with what we already believe to be true. If someone already believes that sugar causes children to be hyperactive, they will likely accept the conclusion of this study because it confirms what they already believe to be true. I think we've all had experiences like this where we like look at some article or some like scientific study and we're like, oh yeah, I could totally agree with that. The reason being because it matches what we already believed previously, not necessarily because we've like critically thought or looked at the results of the study or thought about the argument of the article. Okay, next up is the availability heuristic. This is like a mental shortcut that allows us to make decisions. So heuristic is a shortcut. And the availability heuristic is basically that we tend to think about, I mean, this is kind of obvious, but we tend to think about things that pop into our mind first. So for example, I think in class I gave the example of someone was hit by a car and like a medical professional ran up to help and everyone assumed that it was a nurse. Everyone was like, oh, the nurse is here to help, when really it was a doctor. But we have that heuristic, that shortcut, that mental shortcut that is like women are nurses and men are doctors. So we can be biased in our thinking because we're taking a shortcut. We're making an assumption based on the example that most readily pops into mind. So let's see if I can put that into words. The availability heuristic is the human tendency to draw on examples that first pop into mind. So information that is readily available, that's kind of at the top of our mind, is going to be the example that we draw on to make a decision or to form a belief about the world. And these things can be easily available to us for many different reasons. It could be they were particularly like emotional or vivid experience. So if you had like a really intense experience of something, then you're going to use that for the rest of your life to form the way that you think about the world and the way you make decisions, because it will be at the top of your mind. It will be easily accessible. Okay. So how might that affect, or how might that cause someone to easily accept the conclusion of the study described above? So if someone has a vivid example in their mind of a time when a child ate sugar, then became hyperactive, then they will likely accept the conclusion of this study. So say the person is a parent and they remember a time when they gave their child candy and then their child like became really crazy and super active, then obviously they're going to accept the results of this study because it confirms an example, this like vivid example from their own life that they have at the top of their mind. Okay, and the last one is a misunderstanding of correlational studies. So someone might accept the conclusion that sugar causes hyperactivity if they don't understand that correlation is not causation. So if they're like, oh yeah, that makes sense, there's a positive correlation or relationship between sugar and hyperactivity, then of course sugar must cause hyperactivity. Then that would be like a flaw in their own thinking that would cause them to accept. They'd be like, oh yeah, that makes sense, when really we know that correlation is not the same thing as causation. Okay. Part B. As a follow-up study, the researchers are designing an experiment to test whether sugar causes hyperactivity. So actually I'm going to add that here to make my response a little stronger. So I can say a correlational study does not prove cause and effect. An experiment is the only thing that can prove cause and effect. Okay, so now say we do actually want to prove cause and effect. We want to prove sugar causes children to be hyper. End of story. We'd have to design a controlled experiment to prove that that's true. So a possible hypothesis could be, I'm going to use the if-then structure, and I'm going to use the if independent variable, then dependent variable structure. So actually I'll just type that first. And that's always going to be the structure for a hypothesis. Okay, in this case, my independent variable is sugar. So I could say something like, if a child consumes more sugar, somebody else that consumes sugar. Then the dependent variable would be hyperactivity. Then they